Torsional frequency of the shaft where one end of shaft is fixed and we have a multiple disk attached to this. So we need to use Holzer methods. So now few steps for Holzer methods. First of all, we have to assume angular frequency omega such that the final angle of twist at the fixed end is 0. Then assumed efficiency or assumed frequency omega is the natural frequency. So how this can be done? So let us assume disk 1 theta 1 is 1, then torque T1 is equal to I1 omega square theta 1a, then this 2 theta 2 is equal to theta 1a minus T1 upon K1, and torque T2 is equal to T1 plus I2 omega square theta 2a. And this way we can keep on calculating torque and angle of twist. So at the fixed end, if theta n is 0, then assumed frequency is a natural frequency. Similar procedures to be followed up for the higher natural frequency by changing or assuming the higher angular speed, and mode shape for the torsion natural frequency is plotted on the length of the shaft versus angular displacement. So understanding with an example how torsion frequency is calculated when one end of shaft is fixed. Let us consider two disc system where one end is fixed, shaft end is fixed. So refer picture a shaft having two number of discs. Each disc of mass and outer diameter are 500 kg and 0.2 meter respectively. Shaft diameter is 0.1 meter. Length of shaft between 1 and 2 and 2 and 3 each side is 0.4 meter. Young modulus and Poisson ratio is 2.1 into 10 to the power 11 and 0.03 respectively. And end of shaft is fixed as you calculate the natural frequency and mode shape of this two disc system with fixed end. First of all, mass moment of inertia of disc I1 is equal to Y2. It is calculated as 2.5 kg per meter square, and shaft stiffness are calculated. The polar moment of inertia is 9.8 into 10 to the power minus 6 meter to the power 4, and a stiffness is coming after putting polar moment of inertia G, and it is coming as 2.5 into 10 to the power 6. So first torsion natural frequency using the Holzer methods is coming 618 radian per second, and in hertz after dividing 2 pi it is coming 98.4 hertz. If you see the mode shape, this end is a fixed, so there is no angle of twist, but we have angle of twist at two disc position. Second torsion natural frequency, it is coming at 1618 radian per second, and in hertz it is coming at 157.8 after dividing 2 pi. This is the mode shape where this end is a fixed and we have different deflection or angle of twist at two different discs. So this is the shape of the second torsion natural frequency. So now you have understood how Molgen methods are used for calculating natural frequency of multiple discs attached to the shaft when one end of the shaft is fixed. So hope you like this. Thank you for watching.